Hello everyone, welcome to the exciting journey of learning about AI. With the availability of enormous learning materials across the world, I promise that this learning technique will be unique to you. What are you waiting for? Let us deep dive into the AI learning journey. In this video, we are going to learn about the first principles of AI. Let us first understand what first principle thinking is and why it must be the first step in learning AI. First principle thinking is a mental framework to understand the fundamental truth of a concept that cannot be deduced further. So it is a bottom-up approach. In simple words, it is to understand why something works instead of how something works. First principles thinking has four steps of mental strategy. The first step is to unlearn what you know so far and question every assumption that you have about the concept. The second step is to break down the concept into its basics so that it cannot be deduced further. The third step is to learn something new based on the breakdown that you have. And fourth, or the final step, is to apply the new learning. The first one that you can think of is a simple example would be as designing a wheelchair for a suitcase. The suitcase was invented long before. People are using it to carry their items while they travel from one end to another. But no one would have thought about a wheelchair which could make the whole process more convenient. So whoever has invented or added this wheelchair to the suitcase has applied the first principles of thinking. The second one is building SpaceX, which is a space company of Elon Musk that builds rockets and then sends them to space. So while he tried to get the technology of building rockets from other space companies, it was humongous money that he could not afford. So what Elon did was apply the first principle of thinking to understand the basic building structure of how a rocket could be built, and from there he built the entire rocket from scratch. The cost that was taken to building the rocket was reduced by 80% of what the aerospace industry had asked Elon Musk to share the technology for building the rocket. You can also see how the Amazon digital e-business platform is built. Before the Amazon platform existed, we knew that physical transactions were the only way to buy something, meaning we need to go to a store and that's the only way you can buy things. But Amazon's digital platform has introduced a new and innovative way of doing a transaction, which is a great success. This is how first principles thinking would do wonders in any technology you apply. Let us first understand the definition of artificial intelligence. Alan Turing is a famous scientist and the founding father of artificial intelligence and computing. In the 1940s, he had brought in an interesting definition for AI. Earlier, it was thought that artificial intelligence was an answer to can machines think? But Alan Turing redefined the question as if machines can do things that humans can do. Then we know that the artificial intelligence era has begun. To prove that he had created a game called Imitation Game to understand whether machines have acquired artificial intelligence. It's a very simple game wherein you have three players, player A, player B, and player C. Player A is a computer, player B is a human, and player C is also a human. Player A and player B would be sending data to player C. We can call player C a judge or an evaluator. He would be judging whether the response has come from a human or a machine, that is player A. If player C is not able to differentiate between the responses of a human versus the computer machine, then it means the computer machine has acquired artificial intelligence. You can see that in the current world, large language models like ChatGPT responses can't be differentiated from human responses. It essentially means that, as per Alan Turing's prediction, the artificial intelligence era has begun. AI can be mentioned as a mathematical equation of an algorithm plus data. Here, algorithm means a set of instructions or rules that can be considered as a logic to extract specific patterns. The patterns would lead to a solution to solve a problem. Data is the information from which the required solution or required pattern can be retrieved. In traditional software, let's say humans write these algorithms or the code to find the solution to the problem from the data. In the AI world, AI doesn't need a human to write an algorithm or code for it. It's a learning system. It automatically finds a pattern in the data. Take an example of spam detection in email. If a human has to find a logic to identify spam in your mail, he have to write a logic for the same. Let's say if a word winner indicates it's spam, then you need to write a rule that says if you find a word winner in an email, then move it to a spam folder. If you give it to the AI system, it goes through the entire chunk of email and it finds out that more than 90% of the emails have a word winner, which means that those emails have to be moved to spam and it automatically moves them to the spam folder. That's how an AI system works. It's a learning system that doesn't require manual logic or intervention. We have already seen what an AI means. AI is a mathematical equation of algorithms plus data. Now we will explore the first principles of AI. We will begin with machine learning. It is nothing but a subset of artificial intelligence. It uses statistical or probability algorithms to perform tasks without explicit instructions or hard-coded instructions from humans. What is an algorithm? An algorithm is a set of rules or instructions that tells a computer how to solve a problem or perform a task. A model is nothing but a trained version of a machine learning algorithm. We can say it like a pattern matching machine. For example, if you think of an algorithm as a student studying to understand French from English, the model can be considered as a pattern matching machine, which is a language translator that accurately predicts the French word equivalent of the English word based on user input. The next key concept is artificial neural networks or deep learning techniques. It is a subset of machine learning. It is basically a mathematical structure inspired by brain neurons. In a human neuron cell, there is a connection between one neuron to another neuron. The input that's coming to one neuron will get passed to the other neuron. Similarly, in a neural network, we have information passed from one neuron or node to another. The data being passed from one node to another will vary based on the parameter or weight that has been applied to the neuron. Take an example of image recognition and let's say it has three layers of neurons. In the first layer processing, it would only identify the edges. That input is given to the second layer. The second layer combines the edges and it would create a shape. And that output goes to the third layer. The third and final layer identifies the shape as the face of a human. So that's how a neural network works at a high level. We have also seen about parameters or weight. So this is just an adjustable numeric value that dictates how much one neuron's information can affect the other neuron's outcome. Another important concept is backpropagation or alignment or fine-tuning. It is updating or adjusting the parameter weight values based on the error function or the error outcome of one neuron and then passing it back to the same neural network. This process will be repeated until accuracy is achieved at the expected level. You can think about how in guitar you are setting up the tone. You first check the sound of the string. If the sound does not match with expected sa or pa, then you adjust the peg back and forth and then check again. This is repeated until the strings exhibit the correct sound. Fine-tuning or backpropagation also works the same way. The next important concept is the transformer. We can call it a pattern completion. In old neural network architectures, words in the sentence are processed one word at a time. So it was very difficult for a machine learning model to understand a sentence and the relationship between each word. The transformer architecture solves this problem by introducing a new process wherein the entire sequence of words is processed in parallel. Okay, this way the relationship between each word is identified very quickly. For example, if you type the word cat sit into the transformer based model, it can easily predict the next word as mat. This is done because of the enormous internet data it has been trained with already. The next key concept is called pre-training. So pre-training is nothing but the initial data that is given to the model for reading the data and understanding the patterns of the data. For example, the ChatGPT model has been pre-trained with the entire data so that it can understand different patterns of human input. Fine-tuning or back propagation is tuning this model for a specific task with a curated dataset. For example, you can specialize in a model that only does the coding, or you can create a model that can only do the medical diagnosis. The final and the key important concept is reinforcement learning. Reinforcement learning is a kind of machine learning where a model learns by receiving rewards or penalties for the actions it takes, similar to how humans learn from the consequences of their actions. Now you have created an accurate outcome through the model. Now, the final step is to have a guardrail that validates whether outcomes of the model match the human standards or hand expectations. If there is something wrong, then the model should be stopped from proceeding to the next step. Here is an analogy with an example. Pre-training is something that a person goes through and then reads every single book in a library to understand everything about the world. And fine-tuning is, let's say, he wants to become a doctor and he attends a medical school to specialize in medicine. Reinforcement learning is understanding how to interact with patients and what ethics to follow. In a nutshell, it is like a sculpting process. You start with a block of stone, which is the data. You can use a specific chiseling technique, which we call an algorithm. You follow a blueprint or an objective function and constantly refine your strikes, which we can relate to backpropagation based on your mistakes. You have a block of stone initially, which has the complete data. You have a blueprint, which you know is your goal or objective. You know you can retrieve it from this data or a block of stone. And the technique to retrieve the blueprint from the stone is the algorithm. You can't do it in one step, so you'll be doing multiple strikes. With each strike, you are correcting your outcome by comparing that with the blueprint. The finished state is the statue based on the blueprint. We can call it a model. It should match an objective or blueprint. Finally, we have to have a safety inspection. It must be absolutely safe if you are going to take this statue and put it somewhere like Times Square. Hey, thanks for watching the AI First Principles learning video. You have taken the first step on the AI journey of 1,000 miles. In this video, we have gone through the first principles of AI. In the upcoming videos, we are going to have an interesting discussion about human intelligence versus artificial intelligence. Deep dive into AI technology. Then we'll be talking about why one should learn AI. How is it going to impact your career and life? We will also be having a special video on how to set up and navigate a successful AI journey. Stay tuned.